Hi and welcome to a Kirby Maths video about vectors. It's quite a long video, so as we go through it you might want to pause and rewind just to make sure you've got things straight, especially when I get on to the actual question. So first of all I'm going to look at the convention that we have when we're writing vectors. So this is the convention bit. And if I have a vector that looks like this, a line in a direction with a certain length, I'm going to call that A, and that's a unit vector A. The textbook might not have a line underneath it, but when we're writing it, when we're doing our workings, we need to write a line underneath it to show that it's this unit vector. I could have another vector here which joins on to A. It goes in a different direction to A, and it is not as long as A, and it's different, so this is called B. Now, if I wanted to join up those two vectors, so I went along A first of all and then up to B, I would describe this distance as A plus B, because I'm going along A and then I'm going along B and I'm going in the direction in which these arrows are telling me to go. If I went on a different journey, if I went in this direction, the same distance as B, but in a different direction, this would be minus B. So it is B, but it's in the wrong direction, so it's just called minus B. And then I could describe this journey down here as A minus B, because if I went from this point to this point, not the most direct route, I would go along A, which is this one here, along A, and then I would travel the distance of B in the direction of B, but the wrong way. So this would be A minus B. The other sort of notation we have is if we've got points labelled so that we have got lines like in a triangle, for example. So this is notation. If I had this triangle here, X, Y, and Z, calling this vector A, this vector B, and this vector C. The direction is incredibly important when we're looking at these, so we need to make sure that we know which way our arrows are going. I could write going from X to Y, and I would write it as XY with an arrow indicating across the top that I'm going from X to Y. I'm going from X to Y, and that is equal to the unit vector A. If I was to go from Y to Z, that would be Y to Z. I'm going the correct way along B, so that would just be a normal B. And if I wanted to describe the vector XZ, so this journey along here, in order to get from X to Z, not necessarily going along this most direct route, I would go along A and then along B, or I would go from XY to YZ with my vectors A plus B, and on this diagram that is also equal to C. So X, actually it's not, is it XZ? If I'm going that way from X to Z, that is equal to minus C, because I'm going along C, but I'm going in the wrong direction. The third thing I want to talk about is what happens if a side or a vector is divided in a ratio. So if I had this vector here, and let's call this BC, and there's a point on BC called N, and in the question we are told that we have a ratio between that distance there, BN, and NC. So let's say BN dot dot NC is in the ratio 1 to 3. And what I usually do is I get a different colour pen and I write a 1 here, because that's the BN bit, that's the 1. And then the NC bit, which follows on, is 3. And you can see that if they're in the ratio 1 to 3, that total distance must be worth 4 units of whatever they've divided it up into. So in actual fact, this is a quarter and this is 3/4 of the whole distance BC. So BN, this distance here, going this direction, is equal to a quarter of the whole distance from B to C. And similarly, N to C, so NC, the vector NC, is equal to 3/4 of the distance BC. Okay, so that's how we would use some information on ratios and vectors. Now I'm going to go through a question, an exam question, and this is the question. We have a diagram here, and we have vectors OP, and that's given in the question, is equal to -4a plus 5b. And the vector OQ, which goes from O to Q with the arrow showing you're going from O to Q, is 5a minus 1b. The question asks us, first of all, to express the vector PQ in terms of A and B. So I'm going to answer point here. So P to Q. I would start this question by looking at how I get from P to Q doing a journey. Let me do this in a different colour pen. So P to Q, going along here. I first of all have to go from P down to O, along here. And then once I've got to O, I would have to go along here from O to Q. So to get from P to Q, going the roundabout way, I would have to walk from P to O, that's one vector, and then I would have to go from O to Q, that is the other vector. Then we substitute in these values that we've been given here for those vectors. Now I'm going the wrong way along OP. OP goes in that direction. I want to go the wrong way along that, so I need to change the signs on these elements of the vector. That becomes the opposite of -4a is +4a, so just a normal 4a. And the 5b changes into a -5b. And then I'm adding OQ, and I'm going the correct way along OQ, so that's just a straightforward 5a minus b going in the right direction. Tidying this up, I've got 4a plus 5a, which is 9a, and minus 5b, take away another b, which would be minus 6b altogether. So the vector PQ written in terms of A and B. On to the second part of the question, and before we go on to the second part of the question, we're given an additional bit of information here. It says that R is a point on PQ such that PR to RQ is in the ratio 1 to 2. So we put our point R on here, and it's in the ratio 1 to 2. That is 1, that is 2. So in total, this must be divided up into 3 equal pieces. So this is 1/3, and this is 2/3. And now I have to look at the second part of the question. It says express OR in terms of A and B. Now often on vector questions you actually have to draw in a vector that they're talking about. So they're talking about OR here, and so I have to draw in OR, and the direction is important because the arrow is going from O up to R. To get from O to R, I can go 2 different ways. I could, remember PQ is going that way, I could go from O to Q and then Q to R, or I could go from O to P and then P to R. I'm going to go this way. Okay, it does depend on which way your brain works. Some of you would spot that you would want to go that way and then the wrong way along this part of the vector. I'm going O to P and then P to R. So I'll write that down first of all, OR, this is part B, is equal to OP plus PR. Now I've already worked out what PQ is, and here I know that PR is 1/3 of PQ. And that's why I chose to go that way, because I've got PQ and I don't have to go the wrong way along that particular vector. So 1/3 of PQ, which is 9a minus 6b, and 1/3 of 9 is 3, and 1/3 of 6 is 2. So I have got PR. I know what OP is, because O to P is this value here. So I can just rewrite the whole thing for OR is minus 4a plus 5b, and then add 3a minus 2b. Tidying all of that up for OR, minus 4a plus 3a is minus a, and 5b, take away 2b, is plus 3b. So that is the final answer for that part of the question. What I suggest you do is that you look back through this video, because it is quite a long video and there's quite a lot of stuff in it, and stop it every so often to make sure that you're following exactly where I'm getting these vectors from. And the second thing that I think you should do is, when you are doing a vector question, that you use your pen and you trace over the route you are going to go, as if you were going to walk around that particular route, and where possible avoid going the wrong way along vectors unless you really have to. Thanks for watching.